Hi everyone. So in the last video, we learned about the inverse of a function, right? But you had one part of this that we didn't really talk much about, which is what we call the undefined value of what we call a rational function. I know a rational expression is one where you have variables on the top and underneath. So it forms like a fraction with variables on the top and below, right? So what we want to start off with today is what we call the undefined value undefined value of a rational expression. Right now, rational essentially means fractional, right? The word ratio should be able to tell you that, right? So this is like a fractional expression, right? Or we could say a rational function as well, or a rational relation, right? So something that we need to recall for this section is that we cannot divide by zero. We cannot divide by zero. And this is important, right? We can't find the value of a function or the value of anything when we divide by zero, right? When we divide by zero, when we divide by zero, the the overall expression, the value of the expression is what we say it tends to infinity, right? By zero, right? When we divide by zero, the value of the expression, the value of the expression is what we call undefined. The value of the expression is undefined, right? And that's what we mean by the undefined value of a rational expression. So let's say, for example, we want to find the value for which the following functions or which the following relations are undefined, right? For which the followings are undefined. So let's say number one, let's go with f of x, right? And not just find the value, sorry, find the value of x, find the value of x, right? Yeah, find the value of x. So let's say, for example, we give on this here, x plus 3, as well 2x plus 3 over x minus 1. I know this is an easy one to start off with here. The undefined value of x occurs when the denominator is 0, right? So what we need to remember for this is most importantly is that the denominator, right? To find the undefined value, right? To find the undefined value, undefined value of x, right? What we need to remember is that the denominator, not the numerator don't have anything to do with it. The denominator, not the denominator cannot be equal to 0. So what is the denominator? The denominator in this case is x minus 1, and this cannot be equal to 0. And if we make x the subject, this tells us that x cannot be equal to 1. Now, in case you don't know, this symbol means is not equal to. So what this is telling us here is that x cannot be equal to 1. The reason is that if x is 1, the denominator becomes 0 because 1 minus 1 is 0, and we can't divide by 0. So the undefined value of x is 1. X cannot be equal to 1. All right, let's go again. Let's say we have another relation. We can't say it's a function. We don't know for sure, right? Another relation where we have 5 minus 3x over 5x plus 2. So we want to find the value of x, which will make the denominator 0, right? So to find the undefined value, remember that the denominator, right, cannot be equal to 0 because we can't divide by 0. So this whole thing cannot be equal to 0. So this will give us 5x plus 2 cannot be equal to 0, because if it is 0, we wouldn't get an answer basically. Now, if we solve for x, right, we transpose the 2, it means to add 2 to both sides. So you get 5x cannot be equal to minus 2. Sorry, subtract 2 from both sides. And now we divide both sides by 5. So x cannot be equal to minus 2 over 5. And let's see why. If I substitute minus 2/5 here, 5 into minus 2/5 is 5 into minus 2/5 plus 2 is equal to, this 5 and this 5 will cancel, and you will end up with minus 2 plus 2, which is 0. So this is why x cannot be equal to minus 2/5. Now, a lot of times, you will see the question start with a function like this, and they will state the undefined value right next to the function. So in case you see this is what we mean by the undefined value, and that's what this here means. It tells us what value x cannot be, because if x is that value, the denominator becomes 0, right? Which we don't want to happen. Let's do one more again, right? Let's say we have h of x is equal to 7x plus 2 all over x squared minus 4, right? We want to figure out the values that x can't be equal to. So remember, the denominator cannot be equal to 0. So this tells us that x squared minus 4 cannot be equal to 0. Right now, if x squared minus 4 cannot be equal to 0, if I transpose the negative, well, take away 4, you have to add 4 to both sides. So it becomes x squared cannot be equal to 4. And now if I take the square root of both sides, right, I will get x cannot be equal to the square root of 4. And as you all should know by now, the square root of 4 is not just 4, but there are two numbers when squared will give you 4. And those numbers are 2 or minus 2. So if x is 2, this becomes 2 squared, which is 4 minus 4 is 0. And if x is minus 2 squared is also 4. And 4 minus 4 is 0. Right? So so this is how we find the undefined value. So let's do a couple more of the function questions with rational type. So let's say, for example, we say given f of x is equal to 3x minus 4 over x minus 6. Right? Let's say part 1. So we'll do a couple of different types of questions here with this one. Right? So part E. Right, I decided to just change it up to write all of the questions one time, right? So let's look at this one here now. So we have this function here. F of x is 3x minus 4 over x minus 6. So just write back, always write back down a function to start off a question, right? 3x minus 4 over x minus 6. Good. So first step, the first part of the question, they said to find the undefined value of x. So remember, the undefined value of x is the value of x for which the denominator is 0, right? Because we don't want the denominator to be 0. So for the undefined value, remember that the denominator cannot be 0. So this gives us where x minus 6, because that is the denominator, cannot be equal to 0. So our undefined value of this function is x cannot be equal to 6. Nice and easy question there. Right, let's go with part B. So part B, they want us to evaluate f of negative 2. Now what we need to recall, remember, f of x is f is the name of the function, right, or the instruction. X is your input, and this is how to get the output. So f of negative 2 is 3 into negative 2 minus 4 all over x minus 6, which is negative 2 minus 6. So this will give us 3 by negative 2 is negative 6 minus 4 all over negative 2 minus 6. Right, negative 2, negative 6, take away 4 is negative 10 over negative 8. And 10 over 8, right, the negatives will cancel. 10 divided by 8 is the same as 5 over 4, which is 1 and 1/4. For C-sec maths, you should reduce it to an improper fraction, or sorry, reduce the improper fraction into a mixed number. Right, so let's do part C now. So part C, determine the output when the input is 5. So to determine, remember, this here tells us how to get the output, right? So if this is the output, the input is this here, x is the input. So that's why we just leave it f, not f inverse. So when the input is equal to 5, right, this implies that x is equal to 5. All right, so what we take here now is f of 5 is equal to 3 into 5 minus 4 all over 5 minus 6. So this will give us 3 into 5, 15. 15 minus 4 is 11. And 5 minus 6 is negative 1. And that will give us negative 11. Yeah. So that is so this is your output. So essentially what this is here, when the input is 5, the output is negative 11. According to this equation here. I'll go into that expression. All right, so let's go again. So now part D, they are asking us to find the inverse of f of x. And let's scroll up a little bit here. Yeah, find the inverse of f of x. So remember, with inverse, you first start off with the function. So f of x, and this is part 1, f of x is equal to 3x minus 4 over x minus 6. Our next step from what we did last class, if you feel free to go back to the last class to look it over, we let y be equal to f of x. And this is just for simplicity, right? So this gives us that y is equal to 3x minus 4 over x minus 6. Our next step is interchange x and y. It means wherever it have x, you put y, and wherever it have y, you put x. So this y changes into x, and this x, these two x's, they both change into y's. So this will give us x is equal to 3y minus 4 over y minus 6. And now our next step is that we have to solve for y. We need to make y the subject of the formula. So make y the subject. All right, and as I taught you all in the last video, what we saw here is that we have a variable in the denominator. When we want to make that variable the subject, one of the main methods you could use is what we call cross multiplication. So we multiply both sides by y minus 6. So this gives us x into y minus 6 is equal to 3y minus 4. And now it's just for us to solve for y. We need to gather all the y's on one side. So x by y is xy, x by 6 is 6x is equal to 3y minus 4. Now we want to solve for y, so you need to gather all the y's on one side. So this is xy here. Now this is add 3y, so when you transpose it, it means that to subtract 3y from both sides. So this becomes minus 3y. And now we don't need this x term here, so this is subtract 6, so you have to add 6 to both sides. This becomes 6x minus 4, or minus 4 plus 6x, which is the same thing. Now, through factorization, which you're supposed to know from our quadratic series, we could factor out y. And when you take out y from both of them, xy divided by y is x. 3 divided by y is 3, or minus 3, is equal to 6x minus 4. And now to get y by itself, this is y multiplied by this brackets. So we have to divide both sides by this entire term here. So when you divide both sides by that, you end up with 6x minus 4 over x minus 3. Right now, we let, and this is now the inverse, we let f inverse of x be equal to y. So therefore, the inverse function is 6x minus 4 over x minus 3. Now, if we look at this here now, the undefined value of the inverse function, if the denominator can't be 0, which means that x cannot be equal to 3. Right? Because if x is 3, the denominator becomes 0. So remember what the inverse function is, right? In the regular function, and let's scroll up the regular function, right? In the regular function, this is the output. This tells us how to get the output. In the inverse function, this tells us how to get the input when given a output, right? So that is the part 1, and now part 2. Now something about part 2. They said the word hence. Once you see the word hence in subjects like maths and physics, and any subject actually, to be honest with you, once you see the word hence, it means you have to use what you got above in order to get this here, because there may be other ways, but they want us to use that. So they ask us to evaluate f inverse of 4. So hence, f inverse of 4 is equal to, you just look at the f inverse function, which is this. Right, this is the f inverse function here. So f inverse of 4 is, let's move this down here away from the little tab up there. Right, yeah. F inverse of 4, it just means in f inverse, you replace all your x values with 4. So it becomes 6 into 4 minus 4 over 4 minus 3. And this will give us 24 minus 4 is 20 over 1, which is just 20. Now, just to clarify what this is telling us when the output is 4. When the output is 4, the input is 20, because that is what the inverse gives you. The inverse function takes an output and gives you the input, right? Whereas the regular function takes an input and gives you an output. And now part 3 now, they are asking us to determine the input when the output is 12, right? So when the output is 12, right? What we do is we take this 12 and we substitute it into the inverse function, right? And that will give us the input. So the input is equal to f inverse of 12, which is 6 into 12 minus 4 all over 12 minus 3, which is 72 minus 4 all over 9, right? And this will give us a nice little fraction, and this will give us 68 over 9. Right, and that's it. That's essentially how we work with these questions here. Right, um so yeah, so this is how we work. And again, what does this mean? When the output is 12, the input is 68 over 9. So this is how we work with these types of questions to find inverse and so on. So again, feel free to pause the video at any point. Go ahead and copy it down, try it out for yourself. Right, that's the way to improve in your maths. Right. Now I said I was going to do composite functions in this video, but I feel I will leave composite functions for the last video, where I will do some more combined questions like this, where we have everything in one. You have a inverse question, we have a evaluation question, undefined value, everything in one question, so we can get a little idea on how these questions will come. So with that being said, that is it for this video. A little bit shorter than the others, but um, I want to leave composite functions for the last video of the series. Right, so hopefully it will just be nothing more than 5 videos. So, and it will teach you the almost the entirety of functions for CSEC mathematics. So until the next video, stay safe and keep practicing.